My name is Ariman Khanna, and today I'm going to be giving a lecture on recommender systems. I hope you guys learned something new today. So, first of all, let's start with what are recommender systems? Recommender systems are kind of new and up and coming class of machine learning, and these are algorithms that recommend relevant items to users based on a bunch of different factors. So, basically, recommender systems are kind of what YouTube, Netflix, what they use nowadays. So, what it is let's say that you are watching a video and you like it, so you like the video and you watch a bunch of other videos that maybe are similar to this video in the type of video, or maybe the same person creates these videos. Now, as you keep liking these certain videos, you're going to get recommended these videos, because that's kind of how recommender systems work. Is the things that you like in the past will be recommended to you in the future. So that is one way. Another way is just what's popular. So if like a certain video is really popular, a lot of people are going to get recommended that video because it's popular. So it's kind of just different ways and different methods that they use to recommend videos, but the general concept is the same, in which you get recommended a certain number of videos, for a certain reason, and yeah. So one thing I wanted to talk about was the Netflix prize, which is really interesting to me. In that Netflix, about 10 years ago, I believe it was 2009, they created a competition to see if anyone could create a recommender system that had a better algorithm than the one that Netflix had, and the winner would receive $1 million. So this was really cool to me, because what they wanted to do is see if anyone could create a recommender system that that was more efficient than the one that Netflix had. So maybe it would recommend things that are more relevant to what the user wanted to watch. So they want to see if anyone could create a better algorithm. And surprisingly, a person actually did create an algorithm which was better, and their model was 10% better than Netflix's model, which means that their model definitely was much more specific in the recommendations that the user would get. So, it was much more specific on like the genre maybe of the show or movie, whatever it was that they were watching. The recommended videos or movies were much more specific, and it was much more quick and to get these results. And one thing that was a little bit weird was Netflix actually didn't even use this new recommender system, even though it was much better than theirs. But yeah, otherwise that's besides the point. But yeah, it was pretty cool in my opinion to see how they would introduce a competition like that, to see kind of who could make something that's better than their model. And yeah, someone did. So recommender systems benefit users in finding items that they like, and websites are more personalized to their customers, which leads to better user experience and engagement, because you kind of see the things that you want to see. So let's just take an example that you're buying toys on Amazon. So you are going to be looking at many different toys, but obviously you're not going to find it on the first try. You want to look at a variety of toys. So as you start looking through the toys, your recommendations are slowly going to be changing, and they're going to slowly tailor to your interests. So you're going to be seeing more toys and things of that matter on your recommended items. So that's better for the user, because they're seeing what they want to see. And as a company, that's what you want. For Amazon, they want people to see what they want to see. They don't want people to be looking around their website searching to find the things that they want. They want people to see it right there, right when they enter, because they of course don't care about some things and they care about other things. Like maybe someone cares about toys, but they don't care at all about video games. So they don't want to be seeing video games on their feed or whatever items they see. They want to be seeing the toys and the things that they're interested in. So yeah, that's a way that recommender systems are used. So also for companies, they use recommender systems to increase sales, because it's a better customer experience, like I was just talking about. The websites really are better tailored for the user's needs, and recommendations are much faster when you use recommender systems, because you see what you're interested in and you can order much faster than you used to. And also, more companies can retain customers because the customers, maybe they don't have to spend that extra hassle looking for whatever they want, because because the people are seeing what they're interested in. And it just feels better as a customer knowing that you don't have to waste that time. So yeah. So next slide, we want to talk about how recommender systems work. So there are essentially two different ways in which we recommend items. So first, we recommend items that are popular to most people. So some of the drawbacks of this is that everyone will see the same recommendations, even maybe if you don't want to. And a great example of this is Google News, because in Google News, and I'm sure many other news sources use this, is that you are going to see the news that is most popular, and that's what you're going to see on your first page. And that does make sense, because on a news website, you want to be seeing the most popular news that is going on. You don't really want to be seeing some like super specific news most often. You want to see the big thing, like COVID, or some bigger topic that's going on. That's what most people want to see. So Google News and many other news websites use this more popular way of sorting the information. Now, the other way of sorting information is separating users into categories based on their preferences and recommend items based on their category. So some of the drawbacks of this will be that as more people would be in each category, the number of features would increase, which could cause some problems. So to break this down for you, an example would be, let's say that there's many people, or that there's a group of people who are all interested in a certain genre of movie, right? Now, let's say they're all on Netflix and they all keep watching a certain genre. As more people start to like this genre, and there's more specific parts inside of this genre, it's going to increase the amount of people. So what's going to happen here is everyone in this genre is going to be recommended the same things. But as the people increase, I'm sure that some people are going to be looking at more specifics inside of the genre, or maybe things that kind of are on the edge of being in this genre and another genre. So they're all going to be receiving the same results, although they might not want to, because they're kind of in different parts of it, and they're not all focused on the exact same part of the genre. So that is kind of one of the drawbacks for that method. But yeah. And also a fact I found for recommender systems is that about 70% of the time people spend watching YouTube comes from recommender systems, and 75% of what people watch on Netflix comes from recommender systems. So that shows you that about 3/4 of the whatever you're watching comes from recommender systems, and the videos that you get recommended, and that means that it is effective, and you do see what you want to see, because otherwise people wouldn't be watching the videos that they get recommended if they didn't want to see it. So now our next slide here is going to talk about collaborative filtering methods. So collaborative filtering methods are methods that are based on the past interactions between users and items in order to produce new recommendations. So collaborative filtering is based on the assumption that people who agree on something in the past, on a certain item, you could say, will agree in the future, and they'll like similar objects as they liked in the past. So it's kind of just assuming that what they have liked, they will continue to like, and that's what their recommendations are going to be tailored to. Now, this algorithm for recommender systems is pretty common because it doesn't really require much additional information. All you need to know is what these users have looked at in the past and what they have liked in the past. And from that, you kind of group them up together, the people who like this certain thing in the past, and then you assume that they will all like the similar thing in the future. So yeah, it doesn't really require much additional information, which is good. And the information is usually presented as user item interactions matrix, which is where you would put all of your information on this. Now we're going to talk about user to user collaborative filtering. So this is when making recommendations for users. The user method attempts to connect users with others that have the most similar preferences. So it'll basically calculate a similarity score between two users to find out who's the most similar. So an example that I like for this is, let's say that you have a bunch of people who are all rating a movie. Now, let's say that there's a group of people who all didn't like this movie. They all rated it as a 1, the lowest score. Now, of course, those people will have a low similarity score with people who, rated it as a 9, people who love the movie. Because, they have completely different opinions on this movie and they're not very similar in their opinions. So, the people who, voted a 1 or a 2, they're going to be kind of grouped together because those two people have similar preferences on this specific movie. And now let's say the similar pattern happens for multiple movies, that means they're even more similar to each other because for multiple movies they, agree on a similar thing. And that means that they're going to be much more similar in their overall preferences. So, when you are recommending something to them, you kind of assume that they're going to have similar preferences in what movies they want. So, the similarity can be calculated with the formula right there. So, PUI is the prediction of an item, RVI is the rating given by a user V for the movie I, and SUV is the similarity between the users. Now, now we're going to talk about item to item collaborator filtering. So this is similar to the user method, which we just talked about, but in this one, instead of being grouped with the other users, the idea is that you find items that the user has already liked, and you find similar items that you hope that they will like in the future. So the prediction for this is similar to the user formula, as it's pretty similar. Just some of the values are switched around. But talking more like this is an example is, let's say in the past someone likes Spider-Man, they like Hulk, and they like Captain America. All right. Now in the future you would expect, using the item to item collaborative filtering, that maybe they would like the Avengers, you could say, because it's kind of all in the same topic, right? It's all whatever Marvel movies. So that is a kind of way that you would use this method, in the fact that they have like multiple movies on this kind of category in the past, so you're assuming that they'll like it in the future. So now you, after you have the prediction, you need to calculate the similarity between the items. So yeah, here you have the similarity of I and j, the cosine vector, and then there's the formula right there for that part. So that's after you get the prediction, which is the formula is similar to the user. You still need to calculate the similarity between the items to see if it how good of a recommendation it was. So now we are going to talk about some issues with collaborative filtering systems. So first of all, we have cold start, which is you do need a certain amount of information for the system to work. So you need enough interactions for between the user and the item for the system to work and then properly recommend, items that they would like. So for example, if you set up a new site, it is going to take some time to get the recommendations working properly, because you don't have enough info from the past. You don't know exactly, what these certain people like and what they don't like. And you can't group people together because you're not really sure of it yet, because you don't have enough information. So that is one of the issues with this, and there's really not much you can do because, it's kind of how recommender systems work. You need to have a certain amount of information to be able to recommend on a website like YouTube. So, when a when a website is started, let's say you're starting a new website that's similar to YouTube, it's gonna take some time for your recommender system to work properly, because you need to get the information on these people, what they like, what they don't like, and then you can finally, start recommending for them. And it will take time for it to get better, because of course with these things over time, it's kind of just like training a model. Over time, the model is going to get better. It's going to train. So yeah, that's one of the problems with this. Another one is adding new users to the system. So it's hard to add new people to the system because you don't have any of their previous interactions. So it's going to take time for them to start interacting because you still, again, it's kind of a similar problem here that you face is that you don't know a previous, interaction or whatever they like. When you add a new person, you don't know what they've seen on other websites or what they already like. That's one of those things that you're going to start figuring out, and then your recommender system is going to start working. So now we're going to talk about content-based methods. So content-based methods are methods that recommend items based on items a user liked and the user's viewing history. So for example, if they liked a lot of movies in a certain genre in the past, then they will be recommended a movie of that genre now. So this one is similar to the item method that we talked about earlier, item collaborative filtering. So in this, for example, let's say you like Star Wars 1, 2, and 3. You're going to be recommended Star Wars 4, Star Wars 5, because it's kind of all in that same genre. So, the content-based filtering algorithm finds the cosine of the angle between the profile and item vector, where A is the profile vector and B is the item vector. So, similarity A of B is cosine theta, and then A times B, and then you have the two vectors magnitudes. So now another thing that I want to talk about is hybrid methods. So, for example, Netflix. We've talked about sorting based on popularity and sorting based on a user's preference. Now, a website like Netflix, it kind of uses both because there's a category on Netflix which is the top movies or top shows, and you have your own recommended because Netflix uses a hybrid system where they incorporate the popularity based one and they incorporate the regular one based on a user's preferences. So that's an example of a hybrid method because you know if you just have, let's say you just have a popularity method, then you might be losing some user engagement because they're not seeing exactly what they want to see, and although they're seeing what's popular, they might be interested in some specific stuff. And if you incorporate both, you're kind of getting the best out of both worlds, and the fact that everyone knows what's popular and you get to see your own stuff. So yeah, that's a technique that Netflix uses. So now we're gonna go to content-based approaches. So based on the cosine value of the formula, the movies get arranged in descending order, and one of two approaches is used for recommendation. So there's the top n approach, which is the approach where the top n number of movies are recommended, and you have the rating scale approach, where a certain cosine value is set and all the movies that are above that value are recommended. So let's talk about the top end approach here. So this one you kind of work from the top where you have your certain number n of, let's say 5 for the example here. So you're going to take the top 5 movies. So these are going to be the 5 movies that are the most similar to, what the user has liked in the past. So these are going to be the top 5 best recommendations. So let's say you increase n to 10. Now maybe the 9, 10th, those recommendations are going to be a little bit, farther away from what the user has liked. But those top 5, those top 3, those are going to be like perfect for the user, and they're going to be perfectly tailored to what they have liked in the past. Now, the rating scale approach is you set a value and you kind of have like a threshold, you could say, and every all the movies that are above the value would be recommended. So now, let's say you set your threshold. You would set it somewhere between -1 and 1, which is the range of cosine. So let's say you set it at some point in between. Now all the movies above that point are gonna be recommended. So you kind of control here how much how specific you want to be, or how many movies you want to recommend. So you could set a low threshold, have a bunch of movies, but they might not be as specifically tailored for the user's preferences. Or you could have a higher threshold, which means that there would be less movies, but they're all good. So the way I see is that with the rating scale approach, you kind of work from the bottom, And with the top end approach, you're working from the top to see how many of the best you want. On the rating scale, you're kind of looking at the bottom. What is the minimum number of movies that you want to see? That's what the rating scale approach is. Next, we're going to talk about some of the techniques that are used to build recommender systems. So, one of the common techniques for building a collaborative filtering system is by using a fully connected neural network. So, we've talked about neural networks in the past. So, for this, it'd be an approach is a matrix factorization. So, you need to fill the unknowns of a matrix R. So, you have a big matrix R, and some of the values are null. And our goal is to fill out those values. Now, we also have these two side matrices, U and I, which multiplied to produce R. So you kind of see it in your head, U and I are smaller matrices compared to R, which is a big matrix. So we can find U and I through using neural networks. So we have to match each user and item to a vector with the dimensions m and n, and then for each unit and item u comma x, we concatenate both embeddings of user u and item x to give us a single vector now. And then after you get your single vector, you're going to use backpropagation, which we've talked about with neural networks, to adjust the weights to kind of get your results. So now we're going to talk about matrix factorization, which we kind of brushed on in this slide right here. With neural networks, you kind of use matrix factorization. So matrix factorization is a technique in recommender systems in which you decompose a large user item interaction matrix into two smaller matrices. So you have your user factor matrix and a factor item matrix. So looking at this matrix that we have right here, so we've got U1, U2, U3, U4, and U5, and then we've got D1, D2, D3, and D4. So we see at U1, D1 we have 5, U1, D2 we have 3, and we can see the rest here. So U is units. So in this table we have right here, it's rating movies from a scale of 1 through 5. So you see U1 D1 is a perfect 5, and there are some 1s over at D4 at the very top. So yeah, these are kind of just rating them out of 5, and if there's no value, that means it's a null value. And as we talked about in the previous slides, that's what we want to we want to figure out what those null values are, and we want to fill them out. So here now is a bit of a graphic here. So we have the user item, that's your big matrix, and then you have then you have the user, and then you have the item which you're multiplying to get to the full matrix. So we can divide R, which is the big matrix, into P and Q, the two smaller ones, so that P times Q to the power of T equals R, and that approximates the R matrix. So now this removes the features which don't determine how the user rates a movie. And now when you add the rating of the movie, we get the dot product of the vectors and add them. So there below is after you get the dot product of the vectors and then you add them, you get that right there. Now here's just some matrix factorization math. So we want to find the P and Q by minimizing the error. So we define the update rule for PUK and QKI. So in gradient descent, the update rule is defined by the gradient of the error to be reduced. So now with these two equations, they're going to have the least possible error, because that's what you want in this situation. You want to get the least possible error. So those are our two final equations right there, with PUK and then QKI. So the model had to reduce the error of the dot product between the two matrices, Q and P, and it can predict the values for the null columns now after we trained it. So now we train the model so that we can predict those null values using these equations that we have come up with because we've trained it. So now here are the resources I've used. So yeah, towards data science, medium.com, analytics steps. So yeah, these are the resources, and that's all. So thank you for listening.